Alright, so my name is Daniel Hodgkins, and today I want to talk about the challenges of desalination. Here's an overview of what I'll be talking about today. First, I'm just gonna give a brief introduction to the general process of desalination. And then I'm gonna talk about why desalination should be considered as an option to gain fresh water for society. And then I will talk about the challenges of desalination that we face today and our future goals and strategies to fix these challenges. Alright, so desalination is basically the process that removes minerals from saline water. The salt water is desalinated to produce fresh water suitable for human consumption or for irrigation. And one potential byproduct, of course, is salt. Most of the modern interest in desalination is focused on developing cost-effective strategies of providing fresh water for human use. And aside from recycling wastewater, it's one of the few rainfall-independent water sources. So there are two more traditional strategies for desalination, the most traditional being distillation, which is essentially the boiling of water at less than atmospheric pressure and thus a much lower temperature than normal. And once boiled, you collect the water that has evaporated and then condense it. And then there's also reverse osmosis, which is fairly traditional but more of a modern process. And it's the principal competing process to distillation. And it basically uses membranes, semi-permeable membranes mainly, and pressure to separate the salts from water. Reverse osmosis plant membrane systems typically use less energy than the thermal distillation, which has led to a reduction in overall desalination costs over the past decade. But as I will discuss further later, desalination still remains energy intensive. Alright, so desalination should definitely be considered as of now, just because there's droughts in numerous places around the world, and the population growth is still increasing and continues to increase. For example, in Arizona and Nevada, their respective population growths are 40 and 60% per decade, and both states are in dire need of water. And the recent persistent drought in the Southwest has only added to this problem. Furthermore, fresh water from rivers and springs are being depleted quickly because of this population growth and the lack of concern toward this conservation of water. In the near future, fresh water from these sources will be harder and harder to come by, and draining these sources is also detrimental to the ecosystems dependent on them. And lastly, desalination is such an attractive option, namely because there's such a large supply of saline water. World oceans contain over 97.2% of the planet's water resource. So desalination is still not one of the main ways we get fresh water, because there are many challenges that face desalination. The largest one is its high cost and energy to produce fresh water from salt water. The projected expenditure for desalination equipment and systems has been placed at $15 billion over the next 5 years. This cost is relatively high compared to that of traditional low-cost water sources, such as groundwater and river water collecting. Salt separation from seawater requires a significant amount of energy to overcome the naturally occurring osmotic pressure. And while energy used for seawater desalination is projected to decrease by 10 to 20% in the next 5 years due to technological advances, the total energy demand for conventional water treatment would likely increase by 15 to 20% in the same time frame. So in turn, they sort of balance each other out economically. Another problem is that most of the companies that make desalination equipment see incredibly small profit margins, and they also have a lot of competition. Most of the big companies that used to be involved have gone out of business, such as DuPont, for example, and other companies are struggling. Currently, desalination projects are funded on a case-by-case basis, where most of it comes from some kind of government subsidy. So because of these reasons, funding for research and development is very meager. Considering the lack of success for conventional methods of desalination, we basically need some revolutionary technology, which some have emerged, but none are completely successful. One being membrane distillation. Membrane distillation has been around for a while now, but new technology in that field is still needed for it to be a viable option. The major technology constraint is the need for better membranes with high flux and low wettability. Additionally, beyond better membranes, other challenges are facing this process scale up, which have delayed its commercialization, which include enhancing the water vapor flux, reducing conductive losses in order to maintain flux stability over time, and enhancing thermal efficiency. Furthermore, in the last few decades, a lot of effort has been directed in the use of different renewable energy sources to run desalination processes. And this is brought on, of course, by the high energy needed to run a desalination plant. One renewable energy option is, of course, solar power. And but with solar power comes the issue that not enough regions with saline water also have enough sunlight nearby. A more technical issue with solar energy is the efficiency of the system. During evaporation and the process of condensation, high heat and mass transfer govern the system's efficiency, and consequently the surfaces must be adequately designed within the contradictory aims of heat transfer. Until this efficiency is increased, solar energy will not be a realistic option. Another possibility in the renewable energy realm is geothermal desalination, and its major challenge comes from political, regulatory, and policy reasons. And because of this, there exists so far no industrial-scale geothermal desalination plant. Lastly, waste disposal from the desalination process is a challenge. The salt concentration can be looked at as a possible commodity, or we can just look at how to dispose of it in an environmentally friendly way. There have been studies that show possible adverse effects on the marine life when disposing this highly concentrated salt waste. Dilution methods are being researched to combat this environmentally unfriendly side effect of the disposal. So future goals in the research and development of desalination, one is to increase the efficiency, of course. Without the increased efficiency, it won't be economically feasible to have desalination as the main method of getting fresh water for society. Another goal is to ensure water quality, because if water quality isn't ensured, the consumer is not going to look at desalination as a promising way to obtain fresh water. And then another research topic, as discussed before, is how to handle the concentrate, or in other words, the waste that comes from the desalination process. And the final goal is, of course, to make desalination a significant freshwater source. If we can do this in a cost-effective manner, then that will be huge for society due to the large amount of saline water we have on planet Earth. So specific solutions to these are uncertain, but the strategy is fairly simple. Continued research and development is essential, and to do this we need funding. And for funding, we need awareness of the potential of a low-cost desalination process and how essential that could be to future generations. So that pretty much concludes my presentation on the challenges of desalination. Are there any questions? All right, well, thank you for listening.